Hear me properly? Okay. All right, I hope everyone had a fantastic lunch. My name's Sunny. I come from Telstra Australia. So today I'm going to be starting the IPv6 tutorial called Hypes, Fanfares, Fads, wading through the muddy IPv6 puddle. So today, not just myself, Masataka Mawatari is an engineer in JPIX, and he is the lead for IPv6 deployment and solutions in JPIX, and also one of the co-authors of RFC 6877 as well. So we're very privileged to have him join us today in this session. And he'll be talking a little bit more about 464X. Like, I'm going to free the stage for him to do the talking for that bit. So it's a fairly long agenda today. I'll do the introduction. We'll talk a lot about V6 and V4, what we think the killer app for IPv6 is. Go through a little bit about the wireless network architecture, and then I hand it over to Maratari-san here for introduction about 464XLAT and how it interacts with the network. And then I'll conclude by asking whether or not it is a good or bad thing in your deployment. That's the general agenda. V6. Really, it's here. It's here. From Google, and this is in August, when I logged in to have a look, total IPv6 traffic is at 6.69%. From a previous presentation in this forum, however, apparently that's gone up to about 8% now. So this is real. It's happening. And we all have to face it. As we're talking about in the plenary this morning, different carriers have different requirements. So there are obviously different deployments for IPv6 as well. Just out of 4 different major carriers around the world that has deployed IPv6, you can see that there are slightly different variations on how it's actually deployed. So service provider number 1, without disclosing who they are, has deployed dual stack. And that works for them because they have a very big deployment, it's regionalized, and it makes sense. They have a lot of IP addressing, and the network is optimized for doing that. Service provider 2 and 3 has used a combination of single-stack IPv6, NAT64, DNS64, and 464XLAT. And that seems to work for them because they probably ran out of IPv4 private addresses to allocate for their customers and require a single-stack solution. Service provider 4 has done something slightly differently and used a combination of single-stack and dual-stack, NAT64, DNS hybrid deployment, and 464XLAT. Now, this last one means that they can allow legacy devices and new devices to interact simultaneously in the single APN, or access point name. So, as I said, every carrier has a very unique set of circumstances that dictates which transition method you use. Ultimately, it's up to the carrier to determine which is the best method for your own network. And just out of curiosity, who's from a carrier in this room at the moment? That's okay, because the principles apply simultaneously to enterprise as well. In any method, remember to ensure you have a long-term strategy for the eventual deployment of native IPv6. But apart from going into the technicals, what I really want to do is ask you, why do we need to go to IPv6? So let's have a look at the Ipv4 reality. Now, some managers have asked me this before. Not just managers, but even people in these forums. Why do I want to modify something that's working perfectly fine at the moment? Well, yeah, why should I? I can just put more NAT44 into a network. And you could. Why would I risk going to IPv6? How is changing to IPv6 going to benefit customers and shareholders? I mean, it's a complex change. It's going to affect your customers and ultimately your business. So why do it? IPv6 is just hype. They say we've got a problem. Why should I move to it when everything else is still IPv4? All your content providers aren't doing anything, or most of them aren't. So why should I go to IPv6 when everything else is still IPv4? My favourite. Explain to my grandma why IPv6 is important and why she can't live without it. A bit harder. Ultimately, though, this is the most common question that I get. What is the killer app to convince me to move to IPv6? What is that killer app? You know, I listen to all of that. My gut reaction has to be that. It's infuriating as an engineer. I love to say these, and I can't, but I can do it here. Think back to 100 years ago when we introduced electricity to the countries. Why would I introduce electricity when my oil lamps and candles are working perfectly fine? Why would I? Think about what electricity has done. It's not only provided light, it's provided recharging for your laptops and for your phone. So it's gone beyond the initial use case. Hence its deployment has evolved other technologies as well. Now, the second question I had before was, I can just put more NAT4.4 into a network. Why would I risk going to IPv6? My answer is yes, you can put more into a network. Do you have the budget or license and hardware? Do you have it? Possibly. It's going to get harder and harder to get. What's your long-term strategy? Just before, the third question is, how is changing to IPv6 going to benefit customers and shareholders? For that, a reverse question. How is not changing to v6 going to affect customers and shareholders? If you don't do it, what's going to happen? Oh, v6 is just hype. Why would I move anything to v6 when everything is still v4? Why would I stay on v4 if all the major services my customers are using are moving to IPv6 today? That's Google, Facebook, YouTube. The majority of your users are going to those destinations because their perception of the internet are those locations, and they're all v6 capable. Now, my grandma needs to know why I need to move to IPv6. This is my answer. Grandma, imagine no Skype with your grandkids. We need the internet. It's for communication and, most importantly, to keep in contact with family and friends. Killer app? APNIC says it's the internet. I tend to agree, but you can access the internet with v4 today. So this argument holds, but realistically, businesses are looking for that killer app to make that transition. So, in the end of all that, remember that vendors know about IPv4 address depletion. They really do. And they are prepared to charge you a leg and an arm for IPv4 to v4 NAT4.4 sessions transversing through your CGNAT. And the more sessions there are, the more the money they'll make. So we have one vendor in particular that charges for a certain amount of money for only 5 million sessions. The standards today are saying that every device, you can imagine about 100 sessions per device, as per the standard. So imagine if you have 20 million customers on your network that needs to do NAT4.4 translations. You do the math. Translations are unavoidable. in wireless networks. So you may be using public today, but you're going to run out because APNICs run out of IPv4 public. So you're going to have to move to private v4 eventually, and you're going to have to do a translation. Now, the translations are also required for NAT 6.4 as well. So you need to go from IPv6 public to a public IPv4 as well. So there's another usage. So how do you reduce expenditure in future CapEx and OpEx as your network take-up grows over time? There is no exception. All your traffic needs to be translated eventually. So, IPv4 public addresses is a reality, but private addresses are also running out. And many businesses also reuse IPv4 addresses in different areas. So you can segment and regionalize your network to reuse the IPv4 private address and isolating it in different VPNs. But what happens if you need to merge those VPNs into a central point for access to content? It's going to be more NAT translations again in your network. And have you actually considered how much licensing fees you're going to be paying to vendors and development for additional NAT 444 ALGs? Because you've got to make sure that it's not just a translation, your applications understand that translation as well. So suddenly you've got to cater for double translation in your network. This scenario is a little bit more special because it's 5 to 10 years ahead into the future. Some websites or services in the very near future are going to have absolutely no IPv4 address whatsoever. Your customers, if they're stuck on IPv4, are not going to be able to reach any of these websites or services. Or they're able to reach it, but with inefficiencies because the content providers may decide to deploy NAT 4.6 in some way, shape, or form, but it's still inefficient. So, the only possible way for me to look at this scenario, and I'm going to read it straight from the slide. If you were looking for a business justification to stay on IPv4, it would be this. The IPv4 is working today for my customers, and service availability is key to customer retention and customer spend, which is true. If I want to maintain IPv4 only, I would need to maintain my CGNAT spend on licenses to increase session count, hardware to handle NAT 4.4 translations, purchase more IPv4 public addressing, or perform expensive regionalization exercises with NAT 444 ALG development. But the expense is worth it to maintain service availability for my customers, knowing that it will work for existing services. This will be the only business case justification for staying with IPv4 today. Killer app. Now, you may not agree with the choice that I have made, but let's give it a shot. First of all, there's almost infinite amount of addresses. There's no more protocol translations forever, as we know it. It's better for your business bottom line in a long-term future. Voice over LT and IMS greenfield deployments. Why do IPv4 for voice over LT when you have almost an infinite amount of IPv6 addresses available to you? Is that the killer app? You do IPv6, new path for, it provides a new path for new innovations without dealing with tunneling or translation technologies. Ultimately, however, I reckon it's the Internet of Things, sensor networks and utility networks. We're talking about thousands and thousands of sensors, all needing IP addressing. And the only way you can really do it is IPv6. The question really is your network architecture ready to support this? But grandma gets to keep talking to her grandkids. That's the most important one. So let's address those IPv4 business concerns that you may have. If you go to IPv6, vendors can only make money from you once when you deploy IPv6 Single-Stack, and that is to perform NAT64. So if you do your deployment properly and you're planning properly, you only need to pay once for your translations. The only sessions that require those translations will be IPv6 to IPv4 traffic for NAT64. Granted, NAT64 ALG development is still a problem because NAT44 ALGs are very well developed over time, but NAT64 is still relatively new and still needs to be understood. It's primarily based on what the user is trying to do in a network. But in reality, it's only a problem if you don't know which vendor you're dealing with. The other thing is the majority of your traffic, as I mentioned before, is going to be YouTube, Google, Facebook, etc. And they're all IPv6 only. V4 destination translations are going to deplete over time because your users are going to be going to these other sites that are going to support IPv6 only, and even your content providers are going to support IPv6 only. So the usage of the translations are going to deplete over time and reduce your CapEx and OpEx. Well, we don't need IPv6 private addresses for your customers because you're supposed to be giving them public IPv6 addresses only. There is no such thing as NAT66, there's no requirement for it. And no regionalization is required to isolate your subnetting and your IP addressing because all IPv6 subnets can be different. And for that reason, different regions can directly communicate between each other using IPv6 public addressing. There's no NAT required unless you're communicating with an Ipv4 destination. And your customers with IPv6 Single-Stack with NAT64 can reach Ipv4 destinations with it, and they should be able to reach all current and future IPv4 and IPv6 websites or services with minimal issues. So, after going through that, this is the IPv6 justification. V4 is working today for my customers. The service availability is key to customer retention and customer spend. If I want to maintain V4 only, I will need to maintain my CGNAT, spend on licenses to increase session count, hardware to handle NAT44 translations, purchase more V4 public addressing, or perform expensive regionalization exercises with NAT44 ALG deployment, same as before. But I could spend instead on introducing V6 services, and as it solves my V4 address depletion problems, reduces my CapEx and OpEx expenditure over time, allows the company to begin looking at new innovative future technologies such as IoT without worrying about regionalization, translation, tunneling, issues that are associated with IPv4. You may have to spend a bit, but the expense is worth it to maintain service availability for my customers, knowing that in the future it will work for all existing services and for new IPv6 only services into the future. That would be the business justification I will put forward. Our prediction, and there are carriers who have deployed IPv6 already that have better graphs, but may not disclose them due to confidentiality. But our prediction is that about 50% of your traffic will use IPv6 native, regardless of how you deploy. This type of traffic is Facebook, Akamai, Google. The next 49% is IPv4 destinations. So this is your small businesses that may be sitting on a hosting service that doesn't support IPv6. The last 1% is IPv4 literals and non-protocol agnostic applications that are hard-coded with IPv4. And obviously, we can use 464 XLAT to resolve that. We've been discussing 464 XLAT for about 2 years already. And we're very privileged to have one of the authors here who will explain a bit more about it today. But before we go into that, just a quick terminology refresher for people who don't know wireless networks. So we have an SGSN, which provides signaling information. GGSN, that's basically a gateway to the IP environment from the radio, allocates IP addressing to your handsets via something called PDP requests, Packet Data Protocol. We have an IBR, which is an Internet Border Router. It's like a gateway. The UE is a handset. The HLR is a database containing all of your subscribers. The APN, access point name, you can have a local and a virtual, local, or a real. Think of it as like a switched virtual interface on a Cisco device, or a real VLAN. The PDP is a packet data protocol. It contains your IP information, your mobile number, tunneling information as well to the GGSN and the SGSN. And then the last one is a prefix 64, which is an IPv6 prefix used for v6 address synthesis. And typically we use the /96 for that. And we also call it a well-known prefix or a well-known number. So if you think of a normal network, you've got a host on the left. You could have a layer 2 switching device in the middle, a router, which is basically your gateway, and then an internet router that gets you connected to the internet. So in the scheme of things for wireless networks, basically it's similar to that. So on the bottom there, you've got your host, which is the UE, the SGSN, which is like a big signaling and switching equipment, your GGSN EPG, which is like the radio to IP gateway, and then you've got your Internet Border Router, which does your internet access. This may or may not look familiar to you, but in most deployments, this is what your typical carrier has deployed. You've got your radio network where your UE connects to a tower. Through the radio network, it then connects into the EPG or the GGSN, which is the gateway between the radio and the carrier. In the carrier network, you can have dual stack, because you have to support not just IPv6, you have to support legacy users as well in IPv4. And then you go to the Internet Border Router, which does your NAT translations from private IPv4 to public IPv4. Typically, we assign private IPv4 addresses out of RFC 1918, so your 10/8 range. We've also been using and seen carriers using 100.64 as well, /10, I think that one is. You can use that as well during the transition period. Obviously, you don't want to use one-to-one NAT translations, waste of IP addressing, so you use port address translation so you can increase the translation size. So in order to transition this legacy environment into IPv6, we look at these elements again and see which ones need to be IPv6 enabled or need to be IPv6 aware. First of all, the SGSN, the signaling node, needs to be 3GPP release 9 and above. It's a basic requirement, because anything less than that, you're going to have issues with users who need dual stack, or if you plan to deploy dual stack. Basically, the user black holes. The next is the GGSN, the gateway. You can do IPv6 only and IPv4 v6 dual stack, single bearer PDP contexts. And it's important because the more bearers you have, the more licensing fees you've got to pay, and more spectrum. So, so you have to ensure that if you are doing dual stack, you are doing single bearer. Your Internet Border Router needs to have NAT64 translations. Not only that, it also needs to have application layer gateways. And every vendor is different in what application layer gateway they support. So you have to pick the right one. User equipment. If you're planning to deploy single stack, especially on Android or Windows, 464 XLAT enabled for IPv6 single stack. And it's best if the UI can support v6 or dual stack PDP contexts, just in case. Your database, your HLR database, you need to ensure that it supports IPv6 PDPs and or dual stack PDPs. The APN, which is allocated by the GGSN, can specify specific IPv6 subnet ranges for handsets, and you've got to make sure it also understands IPv6 DNS name servers. The well-known prefix or well-known number, you can use the default or you can use an address which is optimized. You can use a custom address, not necessarily the standard one. Your backhaul, v6 is optional because you can use v4 as a transport, but if you're trying to conserve private IPv4 addresses in your network, well, a lot of vendors actually support IPv6 in a backhaul already. So if you can do it, why not? You can recover those private IPv4 addresses and give it to your handset users instead. Reuse the address. Your DNS, very important bit. You've got to make sure your DNS has full IPv6 connectivity and support. If you really need to, you should have Dns Hd configuration if required. And in a previous presentation, I talked about Dns Hd already. So I'm not going to go into detail here, but it's basically a hash between putting a DNS64 in there and also allowing dual stack to avoid the DNS64 in the same server. Can be good or bad depending on what your deployment is like. And most importantly, also MPLS core. Ensure you have 6PE or 6VPE configured in your core as well. After all that, there's two options. If you want to deploy IPv6 for different types of handsets, you can do it possibly with this method, which is running 3 different APNs, one for v6 only, one for dual stack, and one for v4 only. And ultimately, it's going to be at the user equipment that will decide which APN you use. Or you can use your HLR or database to push certain subscribers onto a particular APN. Now, another carrier that was speaking earlier today in the plenary, they do it slightly differently as well. You know, they detect what the actual handset is. And then depending on the type of handset or the specific model, you can push a particular PDP type, like single stack or dual stack. So there's this method, different APNs for different usage. Another method, well, why don't we just push it all into one APN instead? Save ourselves some headache. Push the control over to the user and let the user decide what they want to connect with. So this is creating a single real APN that supports dual stack and single stack simultaneously and using the Dns Hd configuration I was talking about. So Dns Hd basically is using RFC 7050. And what happens is if the handset responds with a well-known prefix, then the traffic is pushed through DNS64. If it doesn't have a well-known prefix, then it just uses normal DNS. So it's fully dependent on whether the handset has 464 XLAT or not for this setup. Now, apart from the network configuration, we have to look at the user equipment as well. At the moment, Android 4.3 and above supports 464 XLAT. Realistically, we're recommending you to use anything that's 4.4.4 plus or 5.1 plus. Now, I said previously, you can let the user decide on what PDP IP protocol you want to provide. But theoretically, you could do it as well. It's not user dependent. You could force it in the network. We've tested international roaming with IPv6 before as well. It works in some countries. But realistically, because of the different releases of 3GPP out in different carriers globally, getting IPv6 to work for international roaming is going to be very, very hard. At the moment, what we're recommending is the APN roaming protocol to be set to IPv4 only for at least the next 2 years until all the carriers can agree on what to do. But in the very short-term future, that's not the only problem, because Voice over LTE is being launched. Now, what I've got on screen there is Voice over LTE, IMS, with Ravel, with local breakout. At the moment, all of your international roaming goes back to your home country and then goes to the internet. So with local breakout, you can use the local internet access rather than going all the way back home to get onto the internet, which makes your international roaming much quicker and required for Voice over LTE. But the Ravel standard is part of 3GPP release 11. And the majority of carriers around the world today are still on release 9 or lower. So this needs a bit more work from all the carriers around the world. All that being said, so what is 464xLAT? How is it going to benefit me in my IPv6 deployment? With that, I'm going to hand over to Moatari-san from JPIX. Oh.
Sir, I'm Adil. I'm a young fellow from Pakistan. So you just mentioned in one of your slides that using NAT64 and IPv6, we can use the present and future networks for IPv4 and IPv6 with minimal issues. So how you are going to ensure that terminology of minimal issues? Because we couldn't ensure that from IPv4 to IPv6 translation. How can you ensure that with IPv6 to IPv4 translation?
First of all,
do you have a particular strategy for that? How can you ensure minimal issues when you are using NAT64 and IPv6 deployment?
Okay, so first of all, we don't do NAT46 translations in the network. One of the key things to remember during your planning stage is you've got to ensure that you are translating v6 to v4 only, not the other way around. How to ensure this minimum disruption is through testing. In my company, we've tested for 4 years. And this testing is very important to make sure that at least the current applications or the current usage by your customers is tested. And you can easily capture that information through your network. And at minimum, you should test your own content and the most visited sites and applications that your users are using. That being said, we can't test everything, and you can't test everything. So it is minimal because I don't say 100% because 464xLAT assists in a lot of that testing, in that you don't have to do a lot of the tests because 464xLAT is going to do that translation for you for applications that only understands IPv4. But if you know that application, such as Skype, then you can test it. So it's dependent on whether or not you and your team has sufficient testing capabilities and have a sophisticated testing regime. So that's the best way I can answer that at the moment.
Good morning. I'm Masataka Matari from JPIX. And I'm one of co-authors of RFC 687746XAT. Usually, I working for Internet Exchange Network in JPIX. But today, let me talk about technical introduction of 460XAT and background of documenting RFC of 460XAT in IETF. This is an introduction slide. Let me start with this. This tutorial will introduce you the background and technical insight and around 460XAT. And this presentation hopes to be of assistance to you in the 460XAT technique on your network in the future. This is a slide of agenda. Section 1 is background. This section is motivation of IETF and a brief introduction about IPv4 over IPv6. And section 2 is 460XAT network architecture. In this section, I'd like to introduce basic 460XAT architecture and mobile network applicability in 460XAT, and focusing on tethering feature enable. And final section is use case and implementations. This is slide of background around IPv6 at that time. When I thought started to document and standardize 460XAT. Point 1 is little IPv6, but massive spreading CGN. But today, recently, IPv6 growth is finally real, as Sunny's presentation. And second is not 64 DN64 is just not good enough. Getting back to 2011, NAT 64 and DN64 is documented as a RFC in IETF. But NAT 64 DN64 can't work with some applications. For example, Skype or others using IPv4 literal or IPv4 socket. And final point is scarcity and consciousness. At that time, people tended to think IPv4 over IPv6 technology is difficult or complicated. But today, some deployment is there now. This slide shows tested application worked or didn't work with NAT 64 DN64 in the IPv6 only network. This document is Cameron from T-Mobile network, T-Mobile US work. this red cell indicate this application didn't work with NAT64 with DNS64 due to IPv4 literal or IPv4 socket. But green cell indicate this application worked very well with 464XLAT. And this slide shows motivation and uniqueness of 464XLAT. This text is on RFC 6877 section 3, and this point is 3 point. Minimal IPv4 resource requirements, maximum IPv4 efficiency through statistical multiplexing. This means that 464XLAT use stateful translation. If you have a little IPv4 global address block, but you can use 464XLAT. And 2 is no new protocols required quick deployment. This means that 464XLAT is a combination of existing and well-known RFC standards. One is stateful NAT64, another is stateless NAT64. And IPv6 only networks are simpler and therefore less expensive to operate. Dual stack network operation cost is higher than IPv6 only single stack network cost. And this diagram shows the progress of IPv4 by IPv6 technique in IETF. Some years ago, there are many proposals of IPv4 over IPv6 technique. But that discussion have settled nowadays. This time is for deployment phase for 464XLAT. And I introduce the background of documenting RFC document in the IETF. Firstly, I published 00 version in the software in IETF. Software working group was very hot working group of IPv4 over IPv6 discussion. And I published at software working group firstly. And then I updated to 01 version to 02 version. Then I updated to 02 version. Cameron from T-Mobile joined as one of co-authors. He is a mobile network architect in T-Mobile US. I want 464XLAT to adopt to mobile network applicability. I hope 464X that can adapt both wireline and wireless network. And I had introduced in software working group IETF 82 meeting. And in the software working group, I got a comment 464X that is suitable working group is V6 ops and not software working group. So I published draft 00 version again in V6 ops working group. And then 464X that document was approved as a working group document of V6 ops working group. And I updated 464X that 0001, and then I introduced in V6 Ops working group IETF 83. And I got a comment from V6 Ops chair. Chair said that 464X that working group want to change from V6 Ops to Sunset for working group. Sunset for working group treats the method of Sunset Ipv4 protocol. So I introduced 464X that in Sunset for working group and V6 Ops working group. In the IETF 84 meeting, Sunset for working group comment that 464X that is 464X that document continue to discuss in V6 Ops working group. And then 464X that document got approved of working group last call in V6 Ops working group. Discussion phrase changed from working group to IESG. In IESG, 464X that comment got from area director. It's a very useful comment. And IETF last call started, then Regis started in RSC editor queue, finally published as RFC 6877. Next agenda is 464X at network architecture. Let me go back to introduce 464X at again. What is 464X at? Point one is simple technique to provide IPv4 access service across IPv6 network by combining existing and well-known stateful and stateless translation, not stateful NAT64 and stateless NAT64. And NAT464X that has low barriers because, as I talked before, 460X that use stateful translation. This character is very important for APAC emerging country, in my opinion. If you don't have a real IPv4 address, you can use this. And 460X that can apply to wireline network and wireless 3GPP network. And terminology of 460X that. 460X that it began from two translation. PDAT is provider-side translator. PDAT perform stateful NAT64 on the provider's core network, the border of IPv4 and IPv6 network. And another is CDAT is customer-side translator. CDAT performs stateless NAT64. It is located in uplink of end user's network. This feature can apply to broadband router or end user's device such as smartphone. And this diagram shows 460X network architecture. This diagram is for wireline, but mobile network implement prefix delegation mechanism such as DHCP PD. But today's network, DHCP V6 PD implemented in mobile network. This network, in this network architecture, left side is customer side network, and right side is IPv4 server side. CDAT knows two IPv6 prefix for translation. One is CDAT side X8 IPv6 prefix, and another is PDAT side X8 IPv6 prefixes. CDAT side X8 IPv6 prefix is assigned from customers IPv6 prefix greater than /64. And two prefix for translation in CDAT. And this slide shows mobile applicability of 464X. As I talked before, today's mobile network architecture don't use DHCP v6 prefix derivation. So in this mobile network architecture, CDAT feature use two host address. IPv4 host address for XZ and IPv6 host address for XZ. CDAT function is two host address for translation in CDAT. PDAT behavior is same in the previous slide of wireline network and this slide of mobile network. And this slide is focusing on the case of tethering of mobile applicability. DHCP v6 PD don't work in today's mobile network. So tethering case IPv6 /64 prefix extend from radio interface to Wi-Fi interface. And tethering device, tether device is ready for IPv6 and IPv4 worked with 460 XZ. And let me introduce RFCs for the mobile network applicability. RFC 7278. This document describes extending IPv6/64 prefix from a third generation partnership project mobile interface to a LAN link. As I talked at previous slide, this is for mobile device to perform the IPv6 tethering function without DHCP v6 PD. And another is RFC 7335. This document describes IPv4 service continuity prefix. IPv4 host address is needed for 460X at CDAT function inside the end node, such as a smartphone. And final section is use case and implementations. Use case for mobile network. First mobile use case is T-Mobile US. T-Mobile US launched 464X at 2013, and as of February 2015, traffic 50% of traffic is IPv6. And SK Telecom also deployed 460X last year. And in live region use case, Orange Poland also deployed 460X. And wireline BD is JPIX trial service. JPIX trial service started some years ago, and about 20 ISPs participate in trial now. And additional use case in April April 2015, 460X was offered as a conference network. Cisco ASR1K router was used as a CDAT device. It was very stable. And implementations of PDAT. Many router vendors released PDAT devices. AT networks, Cisco systems, F5 networks, Juniper networks, and Seiko solutions. I already tested most of implementations, but all of them is very stable, it's worked very well. Thank you.
Just hang on.
I have one question. May seem silly, but
Yeah.
why is it called 464 when it's kind of 646? Just one sort of silly question. I was just wondering why it's called 464 when it's more of a 646 translation.
Let's ask the author.
Okay.
464 means translation from IPv4 to IPv6 to IPv4. It's called 464, not 646.
All right, so I've just got a few more slides to finish off the presentation. And not in direct challenge to what Motari-san's done. It's 464 XLAP, savior or the devil in disguise. So, Google's embraced the informational RFC, and they've basically deployed it to every single Android device you can possibly see in the world, 4.3 and above. And most vendors like Samsung have embraced it and enabled the code. Obviously dependent on whether the carrier wants to enable it or not, but if they don't say anything, it's usually enabled. The Forbidden Fruit company has gone down a different path. And they've requested that all iOS 9 applications to support IPv6 in the long term, and have provided developers IPv6 dev kits to prepare applications for IPv6. And their devices support v4, v6 and dual stack, but no 464 XLAP. So, 464 XLAP is going to solve reachability issues for you for non-protocol agnostic applications like Skype, or websites, and applications still using v4 literals in their code. And it allows the industry to slowly migrate their v6 services without impacting existing legacy applications and websites. So it's a very, very handy little tool. But depending on how you look at things, we're expecting that the lifetime for 464X to be required in these devices to assist in the transition period to be only about 10 years and not required after. And that's only if the applications are all going to be protocol agnostic. If they're not, then it goes beyond 10 years. But the primary device type in most carriers today may very well be from the Forbidden Fruit company. So you're going to be stuck on single stack v6 with no 464X, or worse yet, dual stack, eating up all your private IPv4 addresses, or public. So, as I said, it will solve your reachability issues for non-protocol agnostic applications, but you're going to be reliant on those application developers to improve their code instead of being reliant on 464X. Is that a good or bad thing? It allows the industry to slowly migrate to v6 services without impacting existing legacy applications. But what if the industry decides to use the technology to prolong IPv4 allocations to devices instead of going to native v6 altogether? So what it does is it allows application developers to have an excuse to stay with IPv4 only instead of improving their code to move to IPv6. The message I want to take away for everyone here today is the industry needs to set some ground rules for the entire industry. And if we are to successfully convince businesses, vendors, manufacturers, engineers that this is the way to go, then we need to do that in a unified, standardized transition method to proceed. And what that does is provide certainty to engineers who are writing those horrible business cases to management on why we need to move down this IPv6 path. So at that, I'll conclude by going to stating that there are operators who have launched IPv6, okay, and our company is looking at launching as well. But ultimately, every carrier has to determine their own path, and there is no single universal answer on how it can be done. On that, thank you very much. Q&A, so does anyone have any questions? Or feel free to come up to stage after we close. So thank you very much. These are our contacts if you would like to get in touch with us. Thank you very much today.